In the last video, I talked about Earth in the first 600 million years. The Archean is the second eon of Earth's history, spanning from 4 to 2.5 billion years ago. This is a colossal amount of time. The Archean Eon literally spans about one-third of the entire age of Earth. And unlike the last eon where we didn't have enough of the rock record to make divisions, now we have enough information to divide this period into four eras. The Eoarchean from 4 to 3.6 billion years ago, the Paleoarchean from 3.6 to 3.2 billion years ago, the Mesoarchean from 3.2 to 2.8 billion years ago, and the Neoarchean from 2.8 to 2.5 billion years ago. The Archean Eon was a real game changer. Sometime in the Paleoarchean, the first life formed. Also, Earth cooled down drastically and experienced its first extinction in the Mesoarchean. But all life at the time was microbial, so fossils aren't nearly as helpful as index fossils than the later periods. So let's jump into the wonders of the Archean, more than twice the size of the previous eon. In order to get started with the Eoarchean, we have to jump back about 100 million years into the Hadean Eon. At this time, the Earth had cooled down, and volcanoes started to get less violent. But infant Earth wasn't out of the woods yet, for the late heavy bombardment was taking place. The late heavy bombardment was what is thought to be a large shower of meteorites bombarding Earth. This started in the Hadean Eon and ended at about the halfway point of the Eoarchean. Some scientists calculate that there was a substantial meteorite about the size that wiped out the dinosaurs in the Cretaceous-Paleogene extinction every 15 million years. Next, we get into the Paleoarchean, spanning from 3.6 to 3.2 billion years ago. This is a really important time in the Archean for two reasons. Once tectonic activity ramped up, we saw the formation of the very first continent. It was named Volbera, and there is no evidence of how this continent looked, but we know that it was formed from parts of current South Africa, Botswana, and parts of Western Australia. Following this event, we finally arrive at the earliest fossil evidence of life. We have some unconfirmed fossils dating to earlier times, but these are the earliest confirmed fossils dating to this revolutionary time. So what are these fossils? Turns out they are cyanobacteria, or blue-green algae. These guys are still alive today, still surviving 3.5 billion years later. At the time, they were the rulers of the Earth, but for now, you can only find them in Shark Bay, Australia, in the form of stromatolites, which we will get into in a later post. Cyanobacteria live in large groups, or else they would overheat and die. For the first time, you might actually see some green covering the coast of Volbera. There's one thing to note when discussing the Precambrian boundaries. The Precambrian is too long ago for us to have a good understanding of the events that took place at the time. So most of the Precambrian boundaries, including this eon's boundary with the Proterozoic eon, is just defined as when two different eons got different enough to split them. As you probably have realized so far through this post, the Archean was one of a kind, an eon where a really unlikely process leading to the formation of life took place. But what was that process? What was the crucial process leading to all the amino acids coming together to form cells? As you probably guessed, we are not sure. There are many theories on this subject, but to start at the beginning, allow me to take you back to the 1950s. A significant and important experiment conducted by Stanley Miller and Harold Urey called the Miller-Urey experiment was about to be conducted. The experiment's goal was to find out exactly how life evolved. Miller and Urey tried to replicate the living conditions around 4.2 billion years ago, when Earth started to gradually cool and liquid water appeared on our surface by comets, as we discussed in the last post. They added many components of the atmosphere and our surface, such as ammonia and water. A few days later, Miller and Urey found chemicals needed to make proteins and other important biosubstances called amino acids. But how did amino acids come together to form cells? First off, there's the panspermia theory, suggesting that life arrived from Earth by a meteor. Another theory is that life began in ice or clay. Next, we have the RNA world theory, suggesting that RNA molecules self-replicated themselves and over time got more complex. Lastly, the Open-Halving theory states that life evolved from a primordial soup, with substances coming together and getting mixed and combined. In the Mesoarchean, we see a new type of event occurring as a result of activity during the Paleoarchean. This phenomenon was extinction, and the first extinction ever to happen was in the form of a glaciation. The Pongola glaciation lasted from 2.9 to 2.7 billion years ago. The idea of the glaciation was proposed when a piece of diamictite rock was found in the Mazan Formation of KwaZulu-Natal in the South African country of Eswatini. The theory was the glaciation was caused when cyanobacteria took in CO2 and released O2. The climate cooled as free oxygen was let loose, forming glaciation. After 200 million years, the glaciers receded. This era also saw the first supercontinent, Kennerland. We can't know how this continent looked, but it stretched from the northern hemisphere to the southern hemisphere. Before the glaciation, the average temperature was much lower than previous times, but a few notches above today's temperature. At the time, the average was around 50 to 85 degrees Celsius, 122 to 185 degrees Fahrenheit. Now we finally arrive at the final era of the Archean, the Neo-Archean, which is heaven compared to the Eoarchean. Here we see the diversification of other types of bacteria. The problem was that cyanobacteria found it hard to photosynthesize, thanks to lack in phosphorus, which is the key in photosynthesizing. This obstacle was solved in the Neo-Archean, when there was a sudden increase of igneous rock, which commonly contains phosphorus. This event appears to be linked with sudden increases in volcanic activity. Following this, paleontologists found some evidence of large amounts of uranium, gold, and sulfur in Kennerland. Scientists are still debating why these deposits formed, and so far no good reason has been come up with. This is also when scientists consider tectonic plates to form. This resulted in more chemicals being mixed up into Earth than from the mantle and crust. Even though this eon is extremely different from modern times, only possessing microbial life that are extremophile animals that can live in inhospitable conditions, take a moment to think about how much has changed in the last 1.5 billion years. Every time the series brings you closer to the present, from the most livable conditions to the harshest conditions on Earth, life, as far as we know, will inevitably find a way. And while you're sitting comfortably in your chair or wherever you are watching this video, think about what life has gone through. Life has pulled through for at least 3 billion years, withstanding anything nature has thrown at them. So now, as we witness the Archean coming to a close, the primitive bacteria and microscopic animals will become the starting point for all the amazing organisms. Thank you for watching my video. Please remember to like and subscribe. The next time you see a cyanobacteria or algae calmly floating or drifting on a lake, remember how significant it is to our world.